So I did want to point out again, this is the happy times. So we're going to be looking at the sine rule. Now, the application of the sine rule is probably not as fun as the actual introduction of the sine rule when there's nice, neat triangles and we just have to find x. That's the good times. The mean wall's got plenty of content related to that. So unlike our trigonometry, we can use our sine rule for any triangle, which is where the power lies. Jump. It's where the power lies, is the fact that we can use it for any triangles, including right angles, but we often don't use it for right angle triangles. It's almost always used for other types of triangles, isosceles, equilateral, obtuse, etc., etc. Now, really useful, and it's important because they don't tell you in exams, use the sine rule. They'll give you a question, you need to identify that you need to use the sine rule. It's in one of these two scenarios. So you've got two angles on one side, or I should have corresponding side, two angles and a corresponding side, one angle and two sides. Now, when you have two angles, you really have three angles, remember? 180 minus the two angles, they give you the third angle. Okay, so you don't need to worry about corresponding sides with this one, but with your one angle and your two sides, you do need to make sure that your side corresponds with your angle. Cool? It'll make a lot more sense. I'm saying things like corresponding and you've probably got no idea. We'll go through some examples and it'll make more sense. So just a few bit of convention stuff. Capital letters denote angles, lowercase letters denote sides. The corresponding angle and side are opposite each other. So if I was looking for, if I had angle A, I would find the side A on the opposite side. And it works for both radians and degrees, which is rather rad, as the kids would say. Didn't read that one? Oh, that's work? Okay. Sorry. That's a triangle. Okay, a non-right angle triangle. I've just got it there so we can see the corresponding sides and angles. You'll see that there's three components. In the first variation of the rule, I have what on top? Side on top divided by the corresponding sine A. A over sine A, B over sine B, C over sine B. Now when we're using this rule in practice, we don't usually use all three, we would just use two. I might write A over sine A is equal to B over sine B. Cool? Now, I don't feel like we need to write this down, but I'm going to do it anyway. We can represent this as sine A on A equals sine B on B. If we flip both sides, it's the same thing. Cool? Why would I want to do that? Why would I change?
It would make it easier to go to the angle.
Correct, so I've got an unknown angle. So this is good for unknown angle. And when we've got an unknown side, we use that one. Because then the unknown's already sitting on the top, so we don't have to multiply and carry on. Sweet. But I'm hoping at this stage we shouldn't need that. Some examples. So the first one I want us to do is label our triangle A, B, C. I'm just going to call this angle A. I'm going to call this side A. I'm going to call this angle Q. Why? Why not? Call this side Q. My rule would then go, what's my unknown angle or side? X. So I'm going to write sine X over, let's make it proper. Sine Q over Q is equal to sine A over A. I then replace those with the letters, or with the values. So I've got sine X over 7 is equal to sine 60 over 10. Good. That equals sine 60 is a half, isn't it? Half?
Yeah.
Yep. And let's squiggle up here and keep going. Sine x is equal to 7 on 20. X is equal to sine -1, 7 on 20. Now, what was my value when I put it in? A degree or a radian? degrees, so I make sure my calculator's in degrees and I shove that in.
Sine 60 would
It is root 3 on 2. Sorry. Thank you. That's 1260. And what do I get? What do I get?
37.3.
37.3. Cool. Happy with that. I'll talk about a few different things with that in a second, but I'm happy to just leave it there for now. So you should have got that. So that's the situation where we're looking for an unknown angle. In the situation we're looking for an unknown side, we go through the same process. I'll be a little bit less tricky this time. I'm just going to call this A, B, and C, which would make that my angle and that my angle. So I'll give you a few seconds to start with that. How many marks? What's the first thing I need to do? Yeah, I can do that. So okay, I write the formula. What should go on top? Side or angle? Doesn't matter, but let's just try and make my life as easy as possible. Side on top. I'm looking for the side A, so it's A on sine A is equal to B on sine B. How do you know it's B on sine B, not C on sine? What's that? It doesn't matter, but I've labelled this side B, and because I've got the known side, I have to use that one. Cool? What's the problem? Don't have A. What is A? 180. Take 100, which is? 8. I've now got 8. So my rule would go A, or not A, I'm replacing A with X. X over sine 80 is equal to 12 over sine 30. Sine 30 is? Sine 30 is? Yep, it is pi 6, but that is equal to? 1/2. 12 divided by 1/2 is? 24. X is equal to 24 sine 80. Put that in your calculators and you get something near 24, 23 or 22? 23.6. I didn't give us units, so that's the end of the question. Capiche? Happy?
Yes.
Comprendo? Rad? Do you dig it? Spitting fire here, no one's picking up. That's one of the worst ones, but I used degrees, so I just thought rather than saying rad and degrees, probably more appropriate. Yay!
Does that mark